Okay, so today I'm going to talk about limiting reagent chemical reactions. So, first thing you're probably asking is what is a limiting reagent? It's exactly what it sounds like. So, limiting reagent is the reactant that will be used first in a chemical reaction. So, the reason this is important is if you have a reaction, you need to be aware of which of your two reactants will run out first because that ratio with your reaction as well as how much fuel you have for this reaction, is going to determine how much product you can make. So you could think of it as a car. When it runs out of gas, the car stops. Same thing with a chemical reaction. Now, I'm going to do another definition real quick. So, the limiting reagent. So, the limiting reagent is important to recognize because it is used to calculate your theoretical yield of product. So you need to know your theoretical yield because you can also find out how efficient your reaction is. So I'm going to show you how to calculate theoretical yield when we find the limiting reagent, but to find efficiency, it's the same thing as percent error. So efficiency, well, not exactly the same, but so you can calculate the efficiency of your reaction by actual over theoretical times 100%. And then your percent error is the same formula. Which is absolute value of actual minus theoretical over theoretical times 100%. Alright, so we're going to be using both of these formulas when you do your lab. Now, I'm going to give you an example. I'm going to just go to a new page. So if you need to copy this, pause it right now. If not, I'm going to keep going. Alright, so here is our example. And I've adjusted the 1, 2, and 3 questions to make it less confusing, because I know a lot of you got lost in the class. So what I'm going to be doing is I'm going to rewrite this equation down there so we keep track of everything. So you have sodium hydroxide reacts with phosphoric acid, which is this, to form sodium phosphate in water. Now we're going to have to calculate the limiting reagent. So let's write that reaction down. So we have 3 moles of NaOH plus 1 mole of phosphoric acid gives us 1 mole of sodium phosphate plus 3 moles of water. And with water being a byproduct, it's not super important. We don't really have to worry about it. It's just one of the products made in an acid-base reaction is water. So anyways, how do we calculate the limiting reagent? Well, let's take all of our info and write it down under the reaction. So we have 35.6 grams sodium hydroxide, and we have 30.8, and let me erase that, 8 grams of phosphoric acid. Okay, so first things first, we have to find the molar mass of pretty much our 3, we have our 2 reactants and our product. So we don't need the molar mass for the product right now, but I'm still going to solve it just because it's a good habit to get into so you have all your calculations that you need and you don't get slowed up. So I'm going to do it in red. So you have molar mass going to put right here NaOH, H3PO4, and we're going to have sodium phosphate, Na3PO4. So I'm going to just use rounded values. It's not too big of a deal. Anyway, so you have 23 for sodium plus 16 for oxygen plus 1 gives you about 40 grams per mole. If you use the unrounded values, you're going to get something like 39.9999 or something. Now for phosphoric acid, we have 3 for 3 hydrogens, 3 times 1, plus I think phosphate's 31 plus 64. Let me double check that real quick because I'm doing all this off the top of my head because I don't have the answer in front of me. Yeah, 31. So, not this. Here we go. So let's add this up. So you have 34 plus 64 equals 98 grams a mole. And then we have sodium phosphate. So you have 69 for 23 times 3 plus 31 plus 64. So this right here is going to give us 100, so roughly 164 grams a mole. Okay, now the easiest way to do this is to convert what our samples were into moles. So the way we're going to do that is by using our molar mass and the mass that we were given. So let me write that down. Convert to moles. Okay, so we have 35.6 grams sodium hydroxide times 1 mole sodium hydroxide over, and that's 40 grams per mole. So 40 grams sodium hydroxide. So let me open the calculator so we can do this. So we have 35.6 divided by 40. And that's going to give us 0.89 mole sodium hydroxide. So let's cross these off because we are in moles of sodium hydroxide now. So now we have to do the same thing for phosphoric acid. So we have 30.8 grams H3PO4 times 1 mole H3PO4 over 98 grams H3PO4. So let's see how this works out. So we have cancel this, do it in the calculator. Let me close this, I don't need that anymore. So we have 30.8 divided by 98. And then that's going to give us 0.314 moles. 0.314 mole of phosphoric acid. So we have everything we need to start solving this. So if you need to pause this for a second, go for it. I'm going to start solving the equation. So we're trying to find out the limiting reagent. So let me copy and paste this again so we can see what we're working with. So copy and then paste. So these right here, so if I wrote a 1 there because that's there, 1, these are our molar ratios for products. What it's saying is you need 3 moles of sodium hydroxide to make 1 mole of sodium phosphate, whereas phosphoric acid is just a 1-to-1 ratio. So these are the ratios we're going to use to calculate our limiting reagent. So I'm going to do sodium hydroxide first. So we have 0.89 mole of sodium hydroxide, and we have to use this ratio to get into moles of sodium phosphate. So we do 1 mole of sodium phosphate divided by 3 moles of sodium hydroxide. So the reason we're doing 3 moles, remember, is it takes 3 to make 1 of these. So it's going to even out. So let's get our answer, because you're going to need a calculator for this. So we have 0.89 divided by 3. And our answer is approximately 0.297 mole of sodium phosphate. So using the amount of sodium hydroxide we have, we're able to make 0.297 moles of sodium phosphate. Here, let me move all this stuff up so I have room to finish this. And then it won't be as messy, because I don't want to go to a new page. So let's do the last part. So actually I'm going to have to just go to a new page probably. But anyways, we have 0.314 mole of phosphoric acid times 1 mole sodium phosphate divided by 1 mole of phosphoric acid. So let me move this up a little bit so we can see what I'm doing. So let's go. We have this cancels, and we're now going to be left with 0.314 mole of sodium phosphate. So whichever one gives us the least amount is our limiting reagent. So our limiting reagent would be sodium hydroxide. And then our excess is what is, our reagent that we have more of. That, so like if we have an excess of something, that means that we could theoretically do more if we had more of the limiting reagent. So let me put these in green. So LR is for limiting reagent and then excess. Okay, let's write the answer down. So what is the limiting reagent? We have determined that it is sodium hydroxide. Now, this part's easy. You know how many moles theoretically you can make because this is it. So let's answer number 2. So we're going to be using that number from now on. So we have 0.297 moles of sodium phosphate. And then we use the molar mass. So we have approximately 164 grams of sodium phosphate over 1 mole of sodium phosphate. So let's see how this works out. Again, use the calculator. So multiply this number times 164, and we're going to end up with approximately 48.65 grams of sodium phosphate. And then that would be the answer to number 2. 48.65 grams Na3PO4. So we have one more question. And if you want to try and solve it by yourself, you can pause the video and then try, and then I'll show you. But if not, I'm going to go ahead and solve that right now. So remember our theoretical yields right here. These are important. This is how you calculate the excess. You take the moles minus the moles, because this is in moles of the same thing, and then you multiply it by the molar mass. And then you convert it back to your excess reagent, which is phosphoric acid. You don't really have to in this one, but it's good practice just in case you have something with a different molar ratio than 1:1. So let's do this. So we have 0.314 mole minus 0.297 mole. So again, this is rounded, but if you want, you can do it this way in your calculator. So we're going to end up with 0.0176. 0.0176 mole Na3PO4. So now we have to convert this back to H3PO4 to convert it into grams of H3PO4. So 0.0176 mole Na3PO4 times 1 mole H3PO4 over 1 mole Na3PO4 times 98 grams H3PO4 divided by 1 mole H3PO4. And I suggest if you're still not comfortable with, dimensional analysis and unit conversions, you need to practice. Like, if you don't know how to do this in one shot, like, you're wasting your time. So here we go. Let's plug this into the calculator. Because really, you're just multiplying this times this, but you need to be sure you're in the correct units. So 0.17, wait, whoops, almost made a mistake. 0.0176 times 98 equals approximately 1.7. So we'll just put it as 3 decimal places. 1.7, was it 725? Yeah. 725 grams H3PO4. And that would be our answer for number 3. So let's write that in. Where did I go? Alright, there we go. So it's 1.725 grams H3PO4. And then that would be the final answer. So if you have any questions about this, just refer to your notes, or you can ask me on Monday or Tuesday. And then that's it.